Hello everyone, my name is Xiangyu. Today, I want to talk about the topic of master scheduling, based on William Stevenson's operations management. The first part, what is master scheduling? Master scheduling is the heart of production planning and culture. It determines the quantities needed to meet demand from all resources and governs key decisions and activities throughout the organization. There have some advantages for master scheduling. The first is valid delivery commitment. Evaluate capacity requirements, provide the necessary information, provide opportunities to strategic objectives, and drive the material requirements planning system. The next slide, master scheduling process overview. There are 5 steps for the process. The first step is develop proposed master scheduling. The second step is conduct rough cut capacities planning. The third step is evaluate feasibility. The first step is authorize the master scheduling. The final step is input into MRP system. Input. The master scheduling has 3 inputs. The beginning inventory, which is the actual quantities on hand from the preceding period. Actual forecast for each period of the schedule. Customers' orders, which are quantities already committed to customers. Output. The master production schedule provides the sales team the information which is useful in negotiating delivery dates with customers. What quantities can be delivered to the customers and when? The quantity of end items that the sales team can promise to deliver on specific dates is called available to promise ATP inventory. There are 3 computations formula. The first one is project on-hand inventory. Project on-hand inventory equals inventory from previous week minus current week's requirements. The second one is project available. Project available equals beginning inventory plus MPS minus the greater of the period's forecast. The next is available to promise. Available to promise equals beginning inventory plus MPS minus customer order before next replenishment. Okay. I want to show an example. United Cashmere Sweaters has authorized the following MPS for her exclusive line of cashmere sweaters. She wants to use the MPS records for permitting future orders. Current orders permitting are included. The MPS order quantities is 60 units. Beginning inventory is 0. Completed the following MPS record. According to the table, we can see there are 12 periods of data here, includes forecast, customers' orders, projected available, available to promise, and MPS. Okay, based on the information, we can know the beginning inventory is 0. We can calculate the project available, this formula. So, let's way to calculate the project available first. The period 1 is 0, plus 16 minus 15 equals 45. Okay, the period 2 project variable equals 45 minus 15 equals 30. So when we use the 15, because the 15 is the larger one. Okay, the period 3 projected variable equals 13 minus 15 equals 15. The next project variable equals 15 minus 15 equals 0. The period 5 project variable is equal 0 minus 20 equals minus 20. And then we need to use minus 20 plus 16. Finally equals 14. So the next period is 40 minus 20 equals 20. And the seventh period is 20 minus 20 equals 0. Okay, the period 8 project variable is 0 minus 20 plus 60 equals 40. The period 9 equal 40 minus 30 equals 10. Okay, the period 10 project variable equals 10 minus 25 plus 60 equals 45. Okay, the next period is 45 minus 25 equals 20. The final period projected variable equals 20 minus 25 plus 16 equals 45. This is the calculator process of project available. Okay, next we need to calculate available to promise ATP. We can use this formula to calculate. So the period 1 ATP equals 0 plus 16 minus 12 plus 10 plus 8 plus 5 equals 25. The next period we need to calculate ATP is 5. The ATP equals 60 minus 0 minus 0 minus 15 equals 45. The period 8 ATP equals 60 minus 0 minus 30 equals 30. Okay, the period 10 ATPs equals 60 minus 0 minus 0 equals 60. The final period equals 60 minus 0 equals 60. There are ATPs calculated process. Okay, let's wait to look at another example. More detail. So as you can see, this table has forecast for 8 weeks. Of the, let's say, 150 units, lead time 1 week, and on hand 15.5. So the first, we need to calculate project on hand first. We can use this formula to calculate. Here, I want to explain this is only being manufactured for the second week. So, there is nothing being in week 1. So week 1's project on hand equals 45 minus 38 equals 17. And week 2 equals 17 minus 13 plus 150 finally equals 137. The week 3 equals 137 minus 30 equals 107. And week 4 projected on hand equals 107 equals 30 minus 30 equals 77. Okay. The next, week 5, project on hand equals 77 equals 35 minus 35 equals 42. The week 7 equals 42 minus 37 equals 7. 35 equals 7. So week 7 equals 7 minus 35 plus 150 equals 122. The final week, the project on hand equals 122 minus 35 equals 87. Okay, the next we need to calculate available to promise ATP. This is the calculated formula for calculate ATP. So the week 1's ATP equals 15.5 minus 38 equals 17. The week 2's ATP equals 150 minus 27 plus 24 plus 8 equals 91. The next, we need to calculate week 7. The ATP equals 150 minus 0, 0, equals 115. Okay, this is my presentation. The next part will introduced by my partners, Tian and Yisu. Thank you.
Now I will continue to explain to everyone. Let's look at the inputs that go into building a master schedule. There are three primary inputs. First, the beginning inventory, the actual quantity on hand from the preceding period. This part of the inventory can be used to meet some customer demands, which helps ease the production pressure for this period. In the MPS, the beginning inventory often appears as the first line of data in the time series table. Next, forecast. It is an estimation of the product demand for the certain period in the future, typically based on historical sales data, market trends, seasonal fluctuations, and other factors. Third, we have customer orders. Customer orders represent confirmed demand from customers, quantities that the company has already committed to deliver by specific due dates. These orders take priority over forecasts because they are contractual obligations. Beyond this, we must also consider operational constraints. First, hiring or firing restrictions. HR policies may limit how quickly we can ramp up or reduce the workforce. Companies may not be able to hire or dismiss employees at any time. Next, safety inventory levels. In order to prevent supply disruptions or inaccuracies in forecasting, the company will establish a safety inventory lower limit. The master schedule must ensure that the inventory does not fall below this level. Space constraints. The warehouse space is limited, and production or stockpiling cannot be unrestricted. The planned production capacity must not exceed the storage capability. Next, perishability of items. Some products have an expiration date, like food, cosmetics, or medicines. It cannot be produced too early and cannot be stored for a long time. Production time must be precisely scheduled to avoid waste and scrap. Next one is market lifetime. Products may have life cycle limitations, such as seasonal goods or high-tech items. If the sales window is missed, the product may become unsellable or obsolete. The production schedule must align closely with the market demand timetable and should neither be too early nor too late. So why this matter in master scheduling? Even a perfect mathematical model will fail in execution if these factors are ignored. The master schedule must be feasible, flexible, and realistic, as these factors are crucial in determining feasibility. Next, let's learn how to calculate this data. One use of the awesome raised MPS is order promising. When a customer places an order for a product but does not expect immediate delivery, the delivery date is notated. The customer typically requests deliver at a future date, and the company decides whether it can promise delivery on that date. This is called order promising. For example, you order a new car custom built at the factory for delivery on graduation day. The company is order promising when it decides whether it can produce the car and deliver it on that date. So let's look at an extended MPS record in table D11. The customer orders row has orders promised to customers for delivery in that time period. The available to promise row shows how many uncommitted units the company has available for delivery at a given time. Next, we look at an example of how to calculate the ATP quantity and the projected available balances. For example, the company has promised 35 units to be delivered in period 1, 25 units for delivery in period 2, and so forth. Using the data shown in table D11, let's look at how we get the numbers. In this case, both the forecast numbers and the customer orders are already filled in. For example, in period 1, the beginning inventory is 110 units. There is no MPS shipment. And since the forecast of 50 is greater than the customer orders, 35, we have 110 plus 0 minus 50 equals 60 projected available at the end of period 1. So the first calculation we need to do are in the projected available row. We take the beginning inventory, add to it any MPS shipment, and subtract the greater of the forecast quantity of all the customer orders. So in period 2, we can calculate like period 1. So in period 2, the beginning inventory is 60 units, and the MPS shipment is 0. Since the forecast of 50 50 is greater than the custom orders 25. So we have 110 plus 0. We have 60 plus 0 minus 50 equals 10 units. So in period 3, the beginning inventory is 10 units. There is MPS shipment. MPS shipment is 125. So, and we can calculate period 3 equals 10 units plus 125 units minus 50 units equals 85 units. So it's projected available. We calculate the ATP quantity for the current period, and each time an MPS replacement order is scheduled. In our example, that means we compute the ATP quantity in periods 1, 3, 5, 7, 8, and 11. We calculate the ATP quantity in the current period differently. Differently from how we calculate it in the future replenishment periods. So in period 1, this is 110 units plus 0, or 110 total units available. From this amount, we subtract the custom orders premise for delivery between now and the next replenishment order. So period 3 in our case. The number of units already promised is 60. Why 60? 35 units for delivery in period 1 and 25 units for delivery in period 2. So after subtracting the 60 units promised from the 110 units available, we still have 50 ATP units for delivery either in period 1, period 2, or at some future date. So look at our book. So it said in the current period, the ATP quantity equals the beginning inventory plus any MPS quantity. These two represent the available inventory we have to work with. So this is our formulation to calculate ATP in current period. So as we said, we calculate the ATP differently at future replenishment periods. In this case, the ATP equals the MPS replenishment quantity less any custom orders promised for delivery between the date of the replenishment received and the next replenishment scheduled. So, for example, a replenishment order of 125 units is arriving in period 3. The custom orders already promised for delivery before the next replenishment order in period 5. Total 45 units by 45, 25 units in period 3 and 20 units in period 4. Of those 124 units arriving, we have already committed 45, leaving 80 units still available to promise. Like this, we can calculate period 4, 5, period 7, and period 8, period 11. Like period 5, the MPS shipment is 125 units. The customer 125 units minus custom orders between current MPS and next scheduled replenishment. So look at this figure. We can see a 0 units in period 5 plus 15 units in period 6. So equals 110 units. This is ATP in period 5. Okay, in periods other than the action bucket, we do not include the beginning inventory since it is not clear what the available amount will be. Remember that we subtract the greater of the forecast or custom orders promised for delivery each period. Thus, if the forecast is greater than the custom orders, we end up with more units in inventory than are reflected on the MPS record. The conclusion: aggregate planning is a mid-term planning method used by enterprises to balance human resources, capacity, and inventory over a future period of 2 to 12 months. By categorizing and integrating products, the planning process is simplified, often utilizing intuitive methods such as chart analysis. A well-developed aggregate plan is further refined into a specific master production schedule, taking into account inventory, orders, and demand forecasts, ultimately determining production scheduling and available to promise inventory. Okay, our class is end. Thank you.